In this video, we are going to be looking at what is DevOps, the ultimate guide to mastering DevOps culture and practices from beginner to pro. And this is what we are going to have as outline for our video. By the end of this video, you will be able to understand software development lifecycle and software delivery before DevOps. You cannot talk about DevOps without talking about software delivery or the software development lifecycle. This is very key and important in understanding the DevOps culture, DevOps principle, or the DevOps philosophy. We are also going to give a brief explanation of what DevOps mean, and we will also be able to identify certain misconceptions and anti-patterns about DevOps, because there are a lot of misconceptions nowadays about what DevOps is and what DevOps does. And we are also going to look at the DevOps pillar, describe the DevOps lifecycle, and even at the end of this video, we will recommend some resources that you can use in order for you to be able to have a deeper mastery of DevOps. And I recommend each and everybody to watch this video to the end to be able to get these resources that they can use to have a proper mastery of DevOps and the DevOps principles. Right, so we are going to start this video by looking at what is software development and who is involved in software development. Just as I said in the beginning, you cannot talk about DevOps without talking about software development. It is impossible, right? And we are also going to look who are the people who are key players in the software development lifecycle or in the software development progress. So now, software development is the end-to-end process of designing, building, testing, delivering, and improving software systems to be able to solve real-world problems and meet user need. That particular process, from the moment where software idea is being incepted to the level where that idea is being implemented and you have a software application that users can actually use to be able to solve whatsoever problem that they have, is what we call software development. And we are going to look more about this continuously in this video. So the traditional IT technical teams that is involved in software development were comprised of two teams. It's actually made up of many teams, but in this video we are going to look at two key teams that are important in our DevOps movement, right? And these two teams are the development teams and the operation teams. The development teams are the teams that are actually responsible for writing and building the application code. For example, let's say you are a restaurant owner and you want to develop an application that users of your restaurant can use in order for them to be able to command food online, make payment online, and also do all the things that you will want them to do with your application. What is going to happen is that you are going to go and meet software developers, and when you meet software developers, you are going to tell out to them what you want, and when you tell them what you want, they are now going to go from the idea you've given them, build your system, design the system, how the application is going to look like. After they design everything, they are going to build that application and then test the application, and if it's working adequately, they will now deliver the application to you and then monitor the application if there is any failure or breakages or any bugs that need to be fixed. So the people that are responsible in writing the application code that is going to perform the various functionality that you want your application to be able to perform, they are what we call the developers, right? They write the application code, they build the application code to make sure that everything is working, and then they are now going to hand over that application to the operation team for them to be able to deploy the application. So the development team focus on features and delivery speed. They focus on improving the application that they have developed, updating the application if there is any update that is necessary, and if there is new feature that you want to add to your application, what is going to happen is that it's the developers that will be working on this to be able to make sure that everything is working very well or your need is being met. And these people focus on speed. They focus on speed of delivery, and whenever they finish working on all the work they have to do, like writing the application code that they have to write and building this application, they are going to hand off this application code to the operation team. And the operation team now are the one that are available in deploying the application. So the developers write the application, they build the application, they test the application if it is necessary, and after they have tested and everything is working, they will submit the application to the operation team. The operation team are now the one that would take this application that the developer have developed and deploy this application, which means launching this application so that users can actually be able to access this application in order for them to be able to perform whatsoever thing they want to perform in this application. And the operation team are also the team that are responsible for setting up the various infrastructure like the server, like the database, the networking, the APIs, and all the rest that are necessary for your application to be able to run adequately without failing and without crashing, right? They take care of the various infrastructure that are important. And whenever they deploy servers, they are also the one that will be managing this server to make sure that all the packages or that are running in that particular server are up to date, right? They are the one that are responsible for this. And these people, they focus on uptime, they focus on performance and also on reproduction. What they want is that the application that they have deployed in the server should be there running at all the time. This is what they are responsible in doing, and they are also responsible in making sure that the application is not only running but it is performing adequately the way it ought to perform. And they also design the system in a way that is highly secured in order to be able to reduce risks that can affect the application. Now, these people are usually involved late in the software development lifecycle with minimal input during development. It is only when the developers have written their application, and if you have a quality assurance team, the quality assurance team have tested the application, and even if you have a security team, the security team have make sure that the application is secured, there are no hard coding, and there are no other security or loopholes that hackers and malware users can be able to use to be able to access your application and cause harm to the application or steal users information. That now the application will be delivered to the operation team for them to just take the application and launch it so that users can be able to use the application, right? So this is normally how the traditional IT teams look like. Now we are going to look at software delivery lifecycle and software delivery before DevOps. How was software being developed actually before DevOps? So when we talk about software delivery lifecycle, it is just a structured process that outlines the various stages that are involved in building and delivering software. The various process that an application has to go through from the moment the idea of building that application has come to the owner of the application to the moment where that application is actually being built and deployed and delivered and is being used. Is what we call software development life cycle. And when you look at this image, you are going to see the various processes that are involved in the software development life cycle. The first process that is involved in the software development life cycle, it is the planning phase. Now during the planning phase, what actually happens is that, for example, if we take our restoration application, you are going to have now this restaurant owner which have a particular restaurant that is running, and you want an application or a software should be developed that these users are going to use to be able to command their food online or perform certain operation online. So what is going to happen is that after he have this idea, he will now come and meet the development team or the software developers. When he meets them, they are going to ask him a series of questions to be able to know what he wants exactly. He is now going to communicate the idea that he has in his mind for his application to be able to do to the developers. Like for example, he can say, I want the users to be able to create account in the application and log into account, and so that personalized content will be delivered to them. I want that the users that will be using this application should have a particular portal where they can message our customer services. I want that this application should be able to have a payment gateway that users, after they have seen what they like and they want to pay, they can actually do this payment. They are going to say everything that they want the application to do. They are going to explain it to this development team, and that is naturally what we call resource or requirement gathering. They are going to gather all the requirements, say everything that they need to the developers, and after they have said everything, what is going to happen is that this will be documented. Everything will be documented, and after everything is being documented, this information is going to be analyzed. The developers are now the development teams are now going to see what can we do to be able to give what these users want to them. What are the various resources that we need for us to be able to start this project and work this project right up to the end, right? There is what we call analysis. All the informations that have been gathered is now going to be analyzed. After analysis phase has been done, we are now going to go to the design phase. The design phase is actually made up of two separate teams. Now we have what we call the UI UX designer, which is the user interface, and the user experience designer. The UI UX designer, they are the one that are responsible in designing the user interface of the application. When we talk about the user interface, this is actually what user sees. This is actually the components of the application that user interact with, right? This is what they design. So the UI UX designer, they design how the application is going to look like, how the application is going to look at the end of the user, how, for example, which color the various buttons that are found on the application is going to be using, everything about the representation, what you see whenever you enter the application. That is what the UI UX designer, they are responsible in doing. Now after they have worked, there is now what we call architectural designer that are going to look at the architecture or the system of the application, and they are going to design it. Now they actually work on back of the scene, like they work mostly in the back end, right? They are the one now that is going to design everything, the database that will be used for storage, and also many other components, how like the various components of the application are going to connect with each other, how when a user click a particular button, what are the various processes that is going to happen, and all the complex thing that you don't want to know is going to be designed by the UI, by the system or architectural designer. Then after the application have been designed, what is going to happen is that this application design now will be delivered to the developers, where they are actually going to write the code that is going to make up this application. This is very important. After the code for the application have been written by the developers, they are now going to test this application. And while this testing is usually being done by the quality assurance team, right? So they are going to do the testing. There are various kind of testing that will be done: unit testing, integration testing, user acceptance test, and all the rest. After all these tests have been done, if all the tests has been passed, what is now going to happen is that the application is going to be deployed, or the application is going to be launched, and it is usually the operation team that are responsible in launching the application. Testing of the application is very important. For example, if you say you want an application where users will be able to create account and log in, you want to make sure to see, can users actually create their account and log in? Is it actually what is working in the application? If that is good, then perfect. All everything that you've specified that you want the application to do, you want to test and make sure that that application can do exactly that before you actually take the application and launch it, or give the application to the users or to the product owners, right? This is very important. After the application have been deployed and it is running, there is now what we call maintenance phase. The maintenance phase is the phase where the application is being monitored, and after the application is being monitored, if there are bugs, if there are errors, if there are crashes, or if there are any problem with that application, those problems are going to be detected, and when they are being detected, they are going to be maintained, right? They are going to be maintained. For example, if for example you wanted your application to be able to do payment, but users are unable to do the payment after the application have been delivered to them, what are you going to do? You are going to notify that. And when you notify that, during the next sprint, you people are going to now come and see what caused this particular problem, how can we fix this particular problem, and you are going to also move from the planning, analysis, design, implementation, testing, and then you come back to the maintenance phase. And that is how the cycle is going to be moving on and on. That is why they call it a software development cycle, because it is just something that is flowing. It's just something, a cycle, like it's just like everything is working in a cycle, right? This is very important. So this is the various process that software application is going to move from the moment that they are being conceived to the moment that they are being delivered. And this matters a lot because it provides a framework to manage software project and ensure quality. If this process was not there, there would have been a lot of confusion in the software development lifecycle. Imagine that a development team, they have not even do the planning of the how of they have not done the planning, they have not done analysis, they have not even done design of how the system is going to look like, and they just go in the implementation, right? Or maybe they have not even done the testing and they just go into the deployment. There is going to be a lot of confusion, and the quality of the system or application that is going to be delivered will not be of high quality. That is why it is always important that this framework should be delivered, so that people will follow this framework, and when this framework is being followed, adequate software are going to be delivered with high efficiency, right? This is very important. Now, the next thing that we are going to see is the various model that we've been used before DevOps in order for us to be able to develop software. And one of the model that we are going to see is what we call the waterfall model. So the waterfall model is a project management methodology that are being used in managing software processes. So it is a linear step by step software development process where each phase finishes before the next phase begins. So when you look at the software development process that we saw in the previous slide, you are going to see that there are different series of stages that are important, from the conception to development or to even deployment and maintenance. And if you look at this diagram here, you are going to see the various phases that are included in the waterfall model. We first of all start with requirement gathering, where all the various requirements and resources that are necessary for the development of that particular software is being gathered and also analyzed. And after all this is finished, we now go to the next phase, which is the design phase. And as we've explained, this phase is made up of two types of designers. We have the UI UX designers, and we also have the system or architectural designers. After the design has been completed, development now will follow, right? And after development, we go to testing, deployment, and maintenance. Now, in this model, which is the waterfall model, if the requirement phase is not finished, you cannot go to the design phase, and unless the design phase is finished, you cannot go to the development phase. You can only go to the next phase in the process only when the current stage has finished. That is only when you have the permission to go to the next stage. And now, when you go to the next stage, if maybe while walking in the next stage you encounter a particular problem, you encounter a particular difficulty, which is as a result of a work that was already done in the previous stage. Let us say you are at this moment at the testing phase, and you realize that there is a particular problem which has been caused by design. You cannot go back again to the design phase to correct the problem, then you develop and then you test again. You will not be able to do that. You lack that flexibility in this model, and that is one of the major limitations of the waterfall model. Once a stage has been finished, it is difficult to go back to that stage, and even impossible at times to go back to this stage. That is why this stage is usually used for project where you have fixed requirement, a project in which there is little flexibility that is needed in that particular project, where everything is predictable. You know exactly what you have to do, and you know exactly the outcome that is going to come after you do that particular this thing. But for a project where there is a lot of flexibility, there is a lot of changes that has to be done, the waterfall model is really not efficient to be able to manage such kind of project. And you have to know that software development is a very flexible project. User requirement and need changes at the same time. You have updates here and there that you have to do, and as a result of all this factor, the waterfall model proved itself to be inefficient to adequately manage software project, right? And what you have to know is that there is little or no overlap between phases. That means that it's always at times difficult for two phases or for two teams to be able to work simultaneously at the same time. The requirement stage has to first of all finish before the design stage start. Though the requirement teams cannot be working at the same time while the design teams are working. These are one of the little drawbacks that is found in this model. The first team finish their work and then they go to the next team, and that is why in this particular model you are going to discover that why these particular requirement teams are working, the testing phase are idle, and why the design phase are working, the testing teams are also idle. There is a lot of idleness in this particular model, so there is wastage of talent and there is also wastage of resources in this particular model as a result of this little or no overlap that takes place between this particular stage. Now the strength of this particular model is that with this model we have clear milestones and documentation. What is actually happening is that before the work is already started, you already know what you want to start, you already know what you need for you to be able to do. You don't go to the field before saying, okay, there is this particular this thing that we ought to use. No, they document everything and they set goals. Like every phase or every stage have their specific goal. The requirement teams we have to gather requirement and they have their goal. They know exactly what they have to do and then they do it. And as a result of that, they usually various teams usually do quality work, right? This is first of all the power of this particular model, and the documentation that is done in this particular model permit in such a way that there is little mistake that is being done. Everything is being scripted, everything is being written down, and if at a particular moment they want to consult everything, they already know where they have to go and look for them to be able to get those information. Now, the limitation of this model is that it is inflexible to changes. The waterfall model is inflexible to changes. As we have explained here, if for example once this work has been done at this phase, everything that has been done here has to continue right to the end. Let me take this simple example. Let us say you are building a house. What is going to happen after the foundation of the house has been laid, and then the building has been done, and even the house have been roofed? If after the foundation have been laid and the building have been done and the house have been roofed, you now discover that maybe the position of the kitchen was wrongly placed or the bedroom was wrongly placed, there is nothing you can do. You just have to continue like that. If you have to if you are really adamant or desirous in changing that, what you have to do is that you have to break down everything, and this is actually one of the limitation of this model. Every project that is managed with this model are inflexible to change. It is very difficult to change something. Once something has been adopted, it is going to be used throughout the various phases by the different team. Even if there is going to be at a higher cost, there is no turning back. This is one of the these are limitation to this. And then now, one of the limitation to this is that because everything is being done linearly, there is usually late feedback and bug detection. What is going to happen is that because there can be no overlap, or because there is little or no collaboration between the teams that are working, what is going to happen is that because for example, if for us to be able to detect a particular problem that is at the testing phase, you need to first of all develop the application. Let me explain it in this simple way. You have phase 1 that finish, you go to phase 2, and then you go to phase 3. Now, each and everything is being done linearly, right? Because the application have to finish being developed, everything is being developed before the application is being tested. You are going to see that you are going to detect bugs lately, and even when these bugs are being detected lately, you will not be able to change them at this particular phase. You will have to push everything to the next sprint, and that is when you will be able to do the various changes that are required in this particular regarding the issue or the problem that you have encountered or that you have faced. So you all have late feedback. Everything is taking a lot of time to be able to do, and when everything takes time to do, user feedback is always at the end when everything has been done. That is when user will be able to see whether they will appreciate what have been done or they do not appreciate it. That is when teams will be able to test to see if there are errors or not. But if everything were being done simultaneously or being done maybe in an overlapping way, there would have been this particular problem would have been solved. And there is also silos between teams which lead to communication gaps. These teams, the waterfall model is made up of different teams. You have the requirement team, design, development, testing, deployment, and all the various teams. And what is happening is that in this model, all these teams are working in isolation or independently. Everyone has their own goal that they are working on, and when they finish working, they give the work to the next team and then they continue. So there is little communication between this team, and as a result of this little communication, there are a lot of errors which is being detected in this system. There are a lot of problems that we have, and there are a lot of confusion that we have due to this poor communication. And as a result of this, the impact of all this limitation is that we have long delivery cycles and high risks of project delays or even project failure. What is going to happen is that if maybe the requirement teams are working here and they have some drawback here, even if they have to take 5 months to be able to solve this particular problem, every other team has to wait for 5 months, and it is only when they have finished their solving the problem in the 5 months that other teams will be able to work, and that is a very very big drawback regarding this. And one of the issue that leads to long delivery cycle is that if for example we take our restoration application that this user for example want to make for his restaurant, if he wants to the developers to develop 5 features in total for him, he meets them here, and these are the developers here. They will go forward and they start. Now in this particular model, everything that has to be done has to be done at once, right? If they have to develop 5 features, they have to finish all those 5 features that constitute that application before they can actually ship the application. So they bundle everything as one and they work on everything at the same time, and then they compile everything and they deliver it to the users. They do not work in sprint, or they do not work in increments, which is the power of another model that we are going to see lately, right? And as a result of this, because they want to finish everything, build all the features, compile everything, and then release them at once, it usually lead to long delivery cycles which can be months and even years depending on all this. And most of these issues can lead to project failure and even delays in the project, right? So this is it about the agile model, waterfall model. We are now going to go to the next slide to look at the agile model in project management. Now, the agile model is also a particular module in project management, which is also the iterative and the adaptive model. So the agile model is an iterative and flexible software development approach which is focused on collaboration, continuous feedback, delivering small incremental improvement frequently. Now, as we saw in the waterfall model, what is happening is that they want to do everything at the same time. If they have 5 features that they want to develop, they will develop all the 5 features, they package everything into one, and then they release it. But the agile model, they focus on delivering small and incrementing everything, improving incrementally. So now let us say if we have to develop the same application as we develop in the waterfall model, we have these 5 features that have to be developed for the restoration store. What is going to happen is that they are going to take these 5 features and they break it into sprint, right? They break it into sprint, a sprint which stays for a period of 1 to 4 weeks. They say that okay, in this first sprint we are going to work on this particular part of the project. This is the goal that we are going to work. We are going to work on feature one, and they take their time, they develop that feature one very well, and then they release that feature one to the users. And also, one of the power of this agile model is that there is collaboration. We saw that in the waterfall model there is little collaboration between the teams, but in the agile model there is a lot of collaboration between the various teams, collaboration between the various stakeholders that are involved in that particular application, the various decision makers, even with the users themselves. This permits them to get feedback from the user at every moment, feedback from other teams at every moment, so that they will actually be able to develop an application that is acceptable to the user and which meet user requirement. But with the waterfall model, there is little collaboration and feedback is always at the end. So now let us say in this, if for example we are in the in the agile model here, at this particular stage here, which is the requirement gathering, what is going to happen is that after the teams have gathered all the requirement, they are now going to sit down. All the teams are there looking, designing everything from scratch. It's not that the development teams will sit on their own end and every other team sit on their end. All the teams comes together, they sit together, they think together, they gather everything, and then now they think on how they can design, develop, test, and do everything, right? Everything is being done in collaboration. There is a lot of communication between the various teams, and even when they are designing everything, they always get to the users and ask their feedback, or they get to the various stakeholders that are responsible in making decision regarding that particular product, and they ask their feedback. Are you comfortable with this? Is there a particular change you want us to make? And after they get all those changes, that is when they will now go and be able to continue the work. So there is continuous feedback. After the requirement, they get feedback. After the design, they get feedback. After the development, they get feedback. There is feedback at all the various stages, and the feedback process is continuous, and this permit them to be able to deliver high quality software which meet user need and which does not take long to be able to deliver. And also the strength of this model is that it is flexible to changes. Unlike the waterfall model where there is little flexibility, the agile model is flexible to changes. So changes can be done on the application, can be done on the requirement, can be done on the resources, can be done on any part of the project that is necessary at any phase, whether it is at the deployment stage, it is at the testing phase, it is at the development phase. At any phase, appropriate changes can be done to be able to deliver high quality product to the users. And it also encourage collaboration and customer feedback. Customers are not isolated, they are involved in the process, and when they are involved, they give positive feedback that permit the teams to build well and do everything adequately. But despite all these advantages that this model offers, there are still some limitations. And what is the limitation of this model? The agile model focuses primarily on the development teams. We saw that the software delivery process is made up of two powerful teams. We have the development teams and the operation team. But the agile model now focus primarily on the development. It doesn't care much about on the operation team. So the operations team still feel themselves disconnected. There is this collaboration between the operation teams and the development team. It is still not adequate. It is still not flowing as it ought to be. As a result of this, there are deployment and infrastructure challenges. All these which could be solved if the various teams were working together, or if the various teams were collaborating together, right? So this is the big problem. Software development is not only about development. Deployment of that application is important to, because you can develop the application, but if the application is not deployed, or even if the application deployed and it crashes every second, users will not actually be able to perform their duty on that application. They will not be happy on that application, and that application can cost the reputation of the company. It can cost even in dollars or in amount, depending on the use of that particular software. So this is very important. So the agile model does not focus on the operation team. It focuses mostly on the deployment, on the development team, and as a result of that, there is still a big gap. Collaboration issue is still existing. Communication issue is still existing, and as a result of this, there is a need for something that can be able to solve this problem. There are other software development lifecycle models like the spiral model, the V model, the prototype model, and you can search more about this. Despite these, there are still some challenges because all these have different approaches, and this model struggle with bringing dev and ops teams together in order to be able to enable continuous delivery. And that is the problem that DevOps have come to be able to work to solve all this problem. So system delivery, this is how it worked before DevOps. You have different teams that are working in isolation. Development teams are working on their own, the testing teams are working on their own, the operation teams are working independently. Everything is working independently. Development are focusing on deploying, developing their application code. They don't care about the operation team, whether they are there. No, they don't care. Everyone is focusing on their own work. The testing, all guys are also there focusing on their work. There is little collaboration between these teams, right? All the teams were working in isolation or independently. And also one of the big problem that we face before DevOps with manual processes, deployment and infrastructure setup were being done by hand. It was not automated. That means for you to be able to deploy, an application in production, you have to be on the CLI running all the Linux command yourself, right? All these things were being done independently. For you to be able to configure, manage all your application server, everything were being done by hand manually. For you to be able to maybe set up pipelines that your application have to go through to be able to work effectively, everything is being done manually. There was little or no automation in the software delivery process, so everything was being done manually. Most of the things that you see today that is being done or is being automated were being done before manually by hand, right? For you to configure your server, you are doing everything by hand, everything. And also one of the big issue that we had before DevOps was long release life cycles. You could take months before releases, and this was slowing down innovation, as this thing was also mostly caused by the waterfall model, right? The waterfall model, because the developers want to develop every feature at the same time before they actually ship the application to production. What was happening is that it was taking a long of time before software were actually being releases, and this was slowing down innovation, right? And also we had delayed feedback issues were being discovered late, increases cost and downtime, and these were all the different issues that the various team and software development environment were facing. There's even what we call the blame culture. Whenever there is a particular issue that was being developed, when being discovered in the application, the devs are going to blame the ops, and the ops are going to blame the devs. So like there was this like kind of conflict between the two teams, the blame culture. Whenever there was a particular failure, or whenever there was a particular problem they discovered in the application development. So as a result of this, DevOps was being needed to be able to fill the gap, right? So these are some of the limitations of the software development lifecycle models that DevOps came to solve. That is a slow sequential handoff, right? Every application development was slow and sequential. There was not flexibility. There was also lack of integration and automation. Like these were all issues that were very important for to be able to solve in order to be able to satisfy the users. But the traditional software development model could not do this. All this poor collaboration between dev and ops environment, as we said, all this were there, and this had business impact because it slowed time to market, lower quality of application, and even frustrated teams. Like just imagine that you are a testing team, or you are even in the deployment team, and you have an application to work. You have a work to be able to. There is a particular work that you have to do in your organization. You have to wait for months for the requirement team to finish, analysis team to finish, design team to finish, development team to finish, testing team to finish before you work. That like this was leading to frustration. You just come in, work, you are idle, you don't have nothing to do, right? This was really a very big issue, and this was not only affecting the developers or the engineers themselves, it was also affecting the business. Just imagine you are a restaurant, and then there is a particular bug or a feature that you have seen on your application. or that is not working perfectly, and you want the developers to be able to correct that error. They will have to first of all set requirement, and then they follow all those status quo processes that they were following for them to be able to do these changes. Why they are taking all those time and they are being satisfied doing that, you are losing money, right? That was really a very big issue, and therefore there was need for DevOps emergence, which is a cultural and technical movement to break the silos, to break the individualism, the independency, and then automate delivery and enable continuous improvement in the DevOps lifecycle. So before, you are going to see the battle between the devs and the ops team. The devs are on their own side, they want change, and the ops are also on their own side, they want stability. And as a result of that, because the two of them had different goal, the developer, they just like their goal or their mission was just to develop application fast as possible using whatsoever tools that excite them, or whatsoever tool that was being documented in the documentation, right? They wanted change, they wanted fast feature, they wanted speed. But the operation team, they wanted stability, they wanted performance, they wanted reliance, right? All of them had two different goals, and because their goal was not working, their goals were different, there was this wall of confusion between them, there was this mismatch between the two teams, there was this difficulty of collaboration between the two teams. But DevOps have come to be able to break this wall of confusion so that the development teams and the ops teams can work together with the same vision and also satisfy their customers, right? This is very, very important. So now, before actually talking about what DevOps is, it is first of all very important for us to talk about what DevOps is not, right? This is very important. DevOps is not Jenkins, DevOps is not Docker, DevOps is not Kubernetes. The fact that you are using Jenkins does not mean you are doing DevOps. You are DevOps, right? The fact that you are using Kubernetes, right? These are various misconceptions that people have about DevOps, which is not true and which has to be corrected. DevOps is not just CI/CD. DevOps is not a single rule or a department in an IT department. No, DevOps is not even a silver bullet. You have to be very keen about this. There are people that because they are using Jenkins, they say that they are DevOps. They are practicing DevOps because they are using Jenkins or because they are using a tool. DevOps is not a toolbox. It is the glue that connects people, processes, and tools. DevOps is more about culture. It's more about a philosophy. It's more about a practices. It's more about collaboration than it is more about tools, right? This is very, very important. DevOps is not tool. Because you are using Kubernetes does not mean you are doing DevOps. DevOps is like a glue, right? That connects systems together with people, with processes, in order to make sure that everything is working simultaneously and everything is working efficiently, right? So DevOps is not a job title. It's not a job title. DevOps is not a job title. It's not even a department that is in a particular organization. So if DevOps is not Jenkins, Docker, Kubernetes, CI/CD, and all the rest, what therefore is the real definition of DevOps? What actually is DevOps? DevOps is a set of practices, principles, and cultural philosophies that bridge the gap between software development and IT operation to enable faster, more reliable software delivery. So the word DevOps is made up of two parts. We have the dev part and then we have the ops part. Dev stand for development and then ops stand for operation. And when we are talking about development here, these are the people who are responsible for writing application code, building this application code, shipping this application code, and iterating. So the developers are responsible for writing application code, they are responsible for building this application, shipping this application, and then restarting back the process again with new features or with update. Now, the ops teams, they are the one now that is responsible for deploying the application, maintaining the application up running, making sure the application is reliable, and also it is secure. So these are two different teams that are working in isolation in the traditional software development process. But now DevOps, which is a practice, which is a principle, which is a cultural philosophy, have come to be able to bridge the gap that is existing between these two teams, so that these two teams can work together in order to be able to enable faster, more reliable software delivery, right? Before DevOps, software delivery process was a very long process, and it was a process that was full of gaps, right? There was actually, these two teams were actually isolated. There was little or no collaboration between these two teams. Every one of them was on their part, working on their part. But the coming of DevOps bridged this gap between these two teams, so that they both of them can work together. So now, when we talk about DevOps being a culture, what do we mean by DevOps being a culture? A culture is a shared beliefs or value or behaviors that shape how people work and interact in an organization. So when we talk about DevOps being a culture, what we actually mean is that DevOps, it is these beliefs, it is this value that developer and operation teams they share together, which makes them to be able to work, which makes them to be able to deliver proper software, right? It is about the shared responsibility that is existing between the teams. Like before the coming of DevOps, when these two teams were working as separate teams, development teams where they were focused on writing application code, and the operation team were focused on deploying. And as a result of this, because these two had different goals, different objectives, there was usually lack of collaboration between these two teams, and there was also lack of shared responsibility. Whenever there is an issue in production, the development teams are going to blame the operation teams, and the operation teams are also going to blame the development team. And as a result of this lack of communication, lack of collaboration that was existing between the two, you are going to see that the software delivery process was very taking a long amount of time, and the application were failing almost all the time. They were not reliable, right? They were not reliable due to lack of communication, due to lack of shared responsibility, lack of accountability, lack of ownership that is existing between these two teams. But DevOps have now come to provide an environment where these two teams can work together in collaboration, where they are working with the same goal, where the dev do not have different goal again from the ops team. Even though the work they are doing is different, they have the same end goal to be able to bring software that are reliable, software that are secured, software that are faster, right? They speed up the software development process. So this is actually the heart of DevOps, creating an environment where there is shared responsibility, where there is collaboration. Every team take ownership of the success of the project they are working on, and also on the failure of the software they are working on. If there is success, all of us we are happy, and if there is failure, we do not blame one another. We actually look for what is the cause of the failure and what can we do to be able to solve this particular problem. They are working together. There is no more gap between them. There is no more blame between the two teams. And DevOps also has made the software environment or the delivery process a process that has made the team, it has given them this freedom, this freedom for them to be able to work. It has provided them an excellent environment where they can work with comfort, where they can test new things and fail without any blame. Before, this was not, they did not have this perfect environment where they can work and then they test and they fail without having any issue, without any blame, or without any problem coming about, right? So DevOps is providing a safe environment where they can actually be able to work, they feel safe to work, to fail, and also to be able to learn, right? They encourage automation and also tooling. When we talk about DevOps being a principle, what is a principle? The principle is a fundamental truth or guidelines that drive consistent decision making and action. This is what principle is. So the DevOps principle is a guiding rule which helps teams to be able to make better decision that is going to accelerate the flow of the software, that is going to make the development of software or the moving of software from the development team to the operation team to the user to move at a very faster rate, that is going to remove all those obstacles or roadblocks that were existing before, that was causing the process to actually be tedious or causing the process to actually be difficult. It is also about feedback, shared responsibility, shared feedback, getting feedback continuously from the users so that they can be able to work on this, to be able to improve on it. This is the DevOps principle. It's all about shared responsibility, continuous feedback, automation, making everything to be able to work automatically, reducing the human intervention in various processes and automating everything so that everything is going to go faster, and also about continuous learning continuously. When they talk about DevOps being a philosophy normally is the overall mindset or belief system that guide the organization purpose and approach to work. So the DevOps philosophy is that it is changing the way organization sees software delivery, right? This is what the DevOps philosophy is there. Software delivery should be a fast and a frequent process. It should not be something that would take all over eternity to be able to do, right? This is about what software delivery is. That software delivery is not just about coding, it is not just about writing application code, it's not just about deployment, but it's about business critical and end to end valuation, right? Like when the DevOps philosophy is about seeing software delivery not just about developers sitting and writing application code on their machine, but something that is of high business value, high business importance, and which is critical for the organization to be able to perform excellently. This is very important. And then the practice is about the specific method, action, or habit which regularly used to implement DevOps principle. This is where now things like CI/CD, containerization, infrastructure as a code, monitoring, and all the rest come into play. This is just like the means that is being used to be able to implement this culture, implement this principle, and also implement this philosophy. But most people, when they are talking about DevOps, they are talking more about the practice. They are talking more about CI/CD, which is not that. Tools without people, tools without processes, tools without automation will not actually lead to anything, right? Before DevOps, there were various tools that were being used to do a lot of things, but because of, despite of the presence of all these tools, the absence of this collaboration, share responsibility that DevOps brought makes things to be difficult. You can give the most powerful tools to a team, but if they are not given an environment where they feel they have this psychological safety, if they are not given an environment where they have this liberty to testing and fail, where they have this ownership of whatsoever thing they are doing, where they have this collaboration, this communication, this shared responsibility between them, or where they have the appropriate mindset, you are going to see that they are going to underperform despite having all the tools that is necessary for them to be able to work. So now, let us look at the three pillars of DevOps. DevOps is all about culture and collaboration, right? It's all about culture and collaboration. That is cross-functional teams working together, having shared responsibility. And this is the people part of DevOps. DevOps is first of all about people before now going to processes where automation and things come about, where manual processes are being automated, where pipelines are being created to automate things, to remove human from to remove most of the human error, and also to create consistent environment in the various servers and all the rest, right? This is very important. So we also have continuous feedback and learning. Like DevOps culture or DevOps promote learning fast, failing fast, and also improving continuously. These are the three pillars of DevOps. You cannot talk about DevOps without talking about culture or collaboration. You can't talk about DevOps without talking about automation. You can't talk about DevOps without talking about continuous feedback or measurement or continuous feedback learning, right? You can't talk about DevOps without talking about this. There is no DevOps without people. There is no DevOps without processes. There is no DevOps without product. This is the pillars of DevOps. This is what is sustaining the DevOps movement. causing it to be going higher and higher, causing organization to be looking for DevOps engineer here and there. This is actually the pillar, the collaboration that it brings, the appropriate cultures that it brings, that automation where things that were taking years to be able to done are now being done in maybe weeks, are now being done in months, because things that were actually being done manually have been automated. Things that were there taking a lot of time, they have been automated for it to be able to take a shorter amount of time. The quality of software that was very low as a result of lack of shared responsibility, as a result of lack of collaboration, because there was no appropriate environment that were being provided for the developers to be able to free and safe to test and work, and also to fail and learn from their failure. Because of all this lacking, all the problem that they being resulted by all this lack have now been filled, and now continuous feedback all the time. You don't have to wait for everything to finish like in the agile, or in the agile model, where you have to wait for a long amount of time before you can actually get feedback from the users. You have continuous feedback, everything is working continuously, and you are learning from it, right? Now, let us look at the DevOps lifecycle. So, the DevOps lifecycle, or the infinity loop, is the end-to-end process of delivering software continuously, from planning right up to the monitoring of the software. And this is usually being done in a loop of constant feedback and improvement. So user feedback are being gotten at every necessary level, and whenever the user feedback are being gotten, they are going to improve where there ought to be improvement, and progress where they ought to progress. And feedback are not only gotten from the users, feedback are also gotten from the necessary stakeholders that are involved in decision making for the application. And feedback at times is also gotten from the application itself, right? When you deploy an application, you test the application to see. From there, you are going to get feedback about the performance of the application, and then you are now going to use that particular feedback in order for you to be able to improve the application. So this is how the circle look like. It is just like a continuous cycle of planning, testing, coding, and all the rest. So we first of all have the planning phase. During this phase, all the requirement for the sprint is being gathered, the goal for the sprint is being set. What are the various features we are going to work on now, what are the various bugs we are going to fix, and what are the various errors that we have to correct in our code, or what are the various updates we have to perform. When the goal is being set and the various requirements for these are being gathered, and the resources that are necessary for these being put in place, now if there is a need for any design, then the design is being done. And after everything is being done, now we transition to the next phase, which is the coding phase. This is actually the phase where the developers are going to write the application code, which is going to perform the software to be able to make the various functionality that it has to make. And after the code has been built, we are going to go to the next phase, which is the build phase. Now in this build phase, the software is being compiled, it is being tested, and it is also being packaged, right? And when this is happening, when all this has happened, we now go to the testing phase. In this testing phase here, the software is being tested for bugs, it's been tested for errors, it's been tested for mistakes. You validate the software using the various tests that has to be performed on the TOS software: unit test, functionality test, integration test, user acceptance test. Everything is being tested here. And when the TOS software have been tested and everything is working perfectly, you now release the software. Releasing the software is deploying the software to production. When you deploy the software to production, you now go forward now to the deploy phase. In this deploy phase, what actually happens is that you give the software now to users. You grant user the access to be able to use this software. And while users are using the software, there is also another step which we call the operation stage. In this stage, you monitor and maintain the software in production so that the software is running adequately. All the resources that it needs for it to be able to function, everything is good. All the various networking connections are established. There is enough space, there is enough storage, there is enough CPU, there is enough memory, and everything that the software need. Everything, you are operating them, you are maintaining them, everything. And while you are maintaining this for the application to be up and running, you also monitor the application itself to see if there are some errors, if there are some bugs that escape the testing phase. Here you monitor everything, and when you monitor, you get feedback. All this feedback that you are going to get from the users, from the application, from the stakeholder, is now going to permit you to schedule the next sprint. When you schedule the next sprint, now you are going to say, okay, we work on this, these are what we discovered, these are the various feedback we've gotten from the user, from the application, from the stakeholder. This is what we have to improve, this is what we have to maybe change. And when you do everything, now you plan back everything, and then you go back to coding, build, test, release, deployment. So this is how the circles continue as far as the application is running and as far as the software process is there, right? Now, let us look at the core DevOps practices. What are the core DevOps practices? When we talk about DevOps, we said DevOps is about a culture, it's about a philosophy. There are set of practices. DevOps is not a tool, right? DevOps is a practice. Now, what are actually these practices that DevOps engineer performs day in and day out? The first practice of DevOps engineer is what we call continuous integration. And when we talk about continuous integration, what is continuous integration? It is just actually the fact where code are being merged and tested continually. Regarding this part, if possible, I'm going to make a video on this, so we'll not actually talk more about this. But when you hear about continuous integration, it's just the fact where developers write their code. After they write the code, they commit the code. After they commit the code, they push it to a central repository in a specific branch. It can be the feature branch, it can be the development branch, whatsoever branch they are working on. After they push this code to this particular branch, it is through a pull request, it is being reviewed, or certain tests are being performed on this code. And when the code is being reviewed and the pull request is being accepted, the code is now going to be merged to a particular branch. It can be to the main branch. When the code is merged to the main branch, then some tests are also going to be performed on this code, right? So when this test has been performed on this code, and the code pass all these various steps, you will now go to the next stage, which is deployment. So continuous integration is about developers writing their code, committing their code in a central repository, and then the code is being built, the various tests being performed on the code, like unit tests, integration tests, functional tests, and all the tests that are being performed on the test. After all these tests is being performed on the test, then continuous integration part stop here, right? We are talking about continuous integration because all this thing is being done continuously. When we look at the DevOps research and assessment metrics, you are going to see the intensity of this. There are companies that are going to follow this continuous integration process maybe like 100 times per day or even more, and there are those, depending on their performance, that can do this like 2 times, 3 times, 4 times per day. It all depends on the teams. So we are talking about continuous integration because this step is being done continuously, almost every day or every week or every month. Now the next step is what we call continuous delivery or continuous deployment. Now when the developers have written their code, committed their code, is being merged, and all the tests have been performed on it, and all the test cases have been passed, if maybe there is a quality assurance test, like quality assurance teams which are going to perform the test, or a security team, they can also check the security and everything. When the software is ready, when the software have passed all the stage and all the checking that have to be done, now continuous delivery and deployment is now the stage where this software is being taken and then deployed in the staging environment, deployed in the production environment, for users to be able to actually access this software, or for continuous tests to be done on this particular software. Now you will see that from in this diagram we have continuous integration here. Then you now go to this review. Now in when we talk about continuous delivery, and continuous deployment, they are almost the same thing, but there is a difference between them. When it comes to continuous delivery, there is human intervention before the code is actually being pushed to the staging environment or in the production environment. But when we talk about continuous deployment, the code is being automatically deployed in staging and production when the code has passed all the tests. So that is actually the difference between them, right? And the next practice is what we call infrastructure as code. Infrastructure as code is a process where you manage your infrastructure using code. You don't actually do everything manually or with the hand, which is prone to error and which is not also consistent, right? You have different environment. You can make mistake, you can forget you can forget maybe to run certain command. You can use certain parameters in one environment and you go to the another environment, you forget the other parameters. So this is how things were being done manually. But infrastructure as code, you set up your infrastructure. If you are using the cloud, you deploy your servers, you deploy your database, you deploy all the various resources using code and no more manually clicking everything on the console or running command manually, right? So that is it. And then now you have automated testing where you run tests without manual effort, right? So for us to be able to perform some of these tests or even all of these tests, at time you don't even need manual effort. You don't do this manually. You automate everything. You have all the, for example, if you are using SonarQube, you have the SonarQube server that have been configured, and then you've connected it with your Jenkins, and whenever the code is being pushed, the code is going to be automatically deployed to SonarQube, and SonarQube is going to do the test automatically without you actually having to intervene in any way, right? This is what we call automated testing. You run all your tests automatically without manual intervention or manual effort at any place. So the only manual effort you have to do is to take time to set the various pipeline that the code is going to go through, and when you are done with this, then everything is now going to be automatic. Now when you deploy your application, you have to monitor and observe this application to see the performance and also to see the health of your application. And this is also what DevOps engineers do. They do monitoring and observability. This is a core practice of DevOps, because it is only through this monitoring and observability that you are going to track failure, that you are going to maybe detect certain bugs that were not detected during the testing, that you are going to see some maybe errors or some failure or some small tweaks that are found in your application that they were not detected. And from there now you are going to gather feedback, you are going to get quick input, then which will permit you to learn fast and then improve fast, and then in the next stage you improve. So these are the core DevOps practices. We have continuous integration, continuous delivery and deployment, infrastructure as code, automated testing, monitoring and feedback, and fast feedback loop, right? Where feedback are being getting quick, you learn from the feedback and then you improve, right? This is how DevOps is, and these are the core DevOps practice. So for you to be a DevOps engineer, you have to be practicing this. For you to say that your team is a DevOps team, or like your team is practicing DevOps, because we say DevOps is not a job title, you have to be practicing continuous integration, continuous delivery, infrastructure as a code. You don't have to be deploying your infrastructure manually, but you have to use code to be able to deploy that to ensure consistency and also reduce error. You have to be doing automated testing without any manual intervention. You need to have a monitoring system where all your applications are being monitored and observed. The system is being tracked, the health and the performance is being tracked, and then you need to get fast feedback, right? You need to get fast feedback at any level or at any stage of the software development lifecycle or of the CI/CD pipeline. This is very important. Now we are going to look at the various DevOps toolchain. What are the DevOps toolchain? These are the various tools that DevOps engineers use that permit them to be able to ensure continuous integration, continuous deployment, infrastructure as code, automated testing, monitoring and observability, and also to be able to do fast feedback, right? So the first tool that DevOps engineers use is what we call the version control tool. What are version control tools? There are just actually tools that you use like Git, GitHub, GitLab, Bitbucket that permit you to be able to monitor the codes that various developers are being deployed, that permit you to give version that can permit you to track changes that is being done on your code, and that also permit you to be able to store your code in a central repository so that many different contributors can contribute to the code, and that you also keep history of the various code that you are working with, so that at a particular moment, if maybe you deploy a particular version of your code and you had problem with that, you can revert back to the previous version of your code, right? These are what version control system does. You have your application, you have different developers that are deploying, that are writing the application, and whenever they do a commit, you keep a version of that. You provide a snapshot of every code that they are running, and then you store that code in a central or in a remote repository, right? And then you also have CI/CD engines. The CI/CD engines that we use, this is what permit us to be able to do automated pipeline for testing, deployment, and all the rest, right? And tools like Jenkins, GitHub Action, GitLab CI/CD, Secure CI, and others are the tools that DevOps engineer use to be able to ensure automation, to be able to ensure continuous integration and continuous delivery or continuous deployment. And the next tool which is used for containers and containers orchestration is Docker, Podman, and Containerd. These are the various containerization tools, and Docker is the popular of all. And regarding container orchestration, we have Kubernetes, Docker Swarm, Amazon ECS, and all the rest. So containerization just permits you to be able to create a lightweight version of your application, create an image of your application, and then container orchestration permits you to be able to deploy this lightweight image of your application that you have created into production or into whatsoever environment that you want. And then you now have monitoring and logging. To be able to monitor your application and collect the logs from the application, you will need tools like Prometheus, Grafana, Datadog, AWS CloudWatch, ELK Stack, Fluentd, Greylog, Splunk, right? These are the various tools that you can use to be able to ensure monitoring and logging. And now for collaboration and feedback, and also incident response, we have tools like Slack, Microsoft Teams, Jira, Trello, Confluence, Notion, PagerDuty, and OpsJD. So as a DevOps engineer, you don't necessarily have to know all of these tools, but for version control, you have to know, at least you must know Git, and then you can now choose, depending on your organization, you can use GitHub or GitLab or Bitbucket or Azure Repo if you want to use managed services, right? And then for CI/CD, you can choose one, and then you learn and you master it. You can either choose Jenkins, GitHub Action, or GitLab CI/CD. These are the ones that are more popular and that are used by some organization. So, and Jenkins being the most popular, which contains like which have plugins for different tools and all, and different tools. So we have Jenkins, so you can start with Jenkins and then later you go to GitHub Action. And then you also have for containerization, you can learn Docker, and then you learn Kubernetes. And for monitoring, you can learn Prometheus, Grafana, and then or Datadog, right? You must not learn everything. You just have to choose one of these, and then you learn, you specify, especially if you're a beginner, you learn it very well, you understand it very well before you can now see how you can stretch your hand to other tools, right? Now, let us look at the business value of DevOps. What are the various values that DevOps practices and culture has brought to businesses? The first value is what we call faster deployment. You are going to see that in the waterfall model and in the agile model, as a result of lack of collaboration between teams, and also as a result of various factors that we name, the deployment speed was very slow. So, but with DevOps now, through DevOps practices, we have faster deployment that permit features to be able to be shipped faster to the users, and also to be able to meet users' need, and also to be able to compete adequately in your environment. So the first thing is faster deployment. Applications are being deployed faster now than before as a result of DevOps practices. And then you also have lower change failure rate, because we have testing at every phase. Before an application is being deployed to production, you have tests that are being performed at every test, at every commit, at every merge request, at every merge. All that there are tests that are being performed on that application, and when tests are being performed on that code, bugs are going to be detected early, and when bugs are being detected early, they are going to be corrected, and all the various fixes are going to be done. And as a result of this, you are going to deliver or deploy more stable software in the production environment, and you are going to have lower change failure rate, right? And then you also have faster recovery from incident. This is also one of the greater advantage that DevOps bring to the business value. You recover fast from incident than before. You also have better and faster problem solving in the DevOps era than in the Agile or in the Waterfall model era. And you also have more room for innovation and even increases team morale and motivation. These are the various values that DevOps brings to your team. Now, let us look at the DevOps success matrix. When we talk about the DevOps success metric, which is the DORA matrix, which DORA stands for DevOps Research and Assessment, they are just key performance indicators that top performing DevOps teams and businesses use to be able to measure software delivery performance and also reliability, right? They are just metrics that DevOps teams use to be able to measure the speed at which they deliver software, right? And also to measure the performance of this software and also the reliability of this software. They measure the intensity at which they actually perform the DevOps movement or the DevOps principles and culture. So this is actually what DevOps success metric is. They are just indicators that teams use to be able to measure their software delivery performance, and we are going to look at some of these metrics right now. So the first metrics here that teams use to be able to measure their performance and reliability is what we call the deployment frequency. Now when we talk about deployment frequency, it is how it is just like the frequency is how long code is being deployed to production from changes or from every single commit, right? So how long are code being deployed into production every day? What are the frequency of code being deployed to production? How many times are code deployed to production every day after every change has been made, right? And for some teams, their deployment frequency is elite. That means that they deploy multiple times per day in production, right? This is what their elite means here. That means they deploy multiple times per day in production, and this is actually of bigger teams or for companies like Netflix, Microsoft, Amazon, and others like Google, right? They deploy multiple times per day in production, and there are other teams that deploy between one time per day to one time per week in the production after every code change have been performed, and there are others that they deploy only between once per week and once per month. And when they deploy between once per week and once per month, that means their deployment frequency is low. And those that deploy between once per day and once per week, their deployment frequency is high. And those that deploy just between once per month and once every 6 months, their deployment frequency is low. So every organization, they look at how many times they deploy per week or per month or per day, and then now they rate themselves either whether they are elite, they are high, they are medium, and they are low. And then you also have lead time for changes, right? Lead time for changes. When we talk about lead time for changes, it is how long will a code change that have been performed on application will be reflected in the production environment. How long will code changes be deployed in the production environment? And the lead time for changes is for the li teams are usually less than 1 day. So if for example you perform a change on your code today, and in less than 1 day that code will be deployed in production, that code will be reflected in production, then your lead for changes is less than 1 day. But if it takes you between 1 day and 1 week, then your lead for changes is high. If it will take you between 1 week and 1 month, then your lead for changes is medium. And if it will take you between 1 month and 6 months, your lead for changes is low. Now we also have what we call change failure rate. Change failure rate is like if for example a particular change has been done to your code, how what is the probability or the percentage that this change that you've done to this code will lead to the application failing in production. And for some teams, The change failure rate is, if it is 0 to 15%, then they are elite, and there are others also. If it's 0 to 15% still, they are high, and also 0 to 15% still means medium. So there is almost relatively no difference here. But if you have, like, you have 46 to 60% that any single change that has been done on your application code is going to lead to failure in production, crashing of the application, then your change failure rate is low. And then now we have the last one, which is mean time to recovery. After now that you have done this change, and this change have lead to a failure in production, what is the mean time, or what is the average time that will take for you to be able to recover from this failure, for you to be able to fix this the problem that you have, and we should also be fixed in production, not only in the development environment, right? So the for some teams, the mean time to recovery is less than an hour, and there are some teams that, and these are allied teams, and there are those that their lead time to their mean time to recovery is less than 1 day, and these are high performer teams. And there are those that theirs is less than 1 day, which are medium teams, and there are others that is between 1 week and 1 month, and these are low performance team. So these are the various metrics that every team use to be able to measure their software delivery process and also their reliability. All these things is to answer the question, how well are we delivering software, how well are we practicing DevOps, right? How well is the DevOps culture indebted in our environment? And it is very important that every team have this DevOps metric set up for them. If you have difficulties in setting this up, you can contact me using the email in the description, and we can see how we are going to do this for your team, right? Now, let us look now at some common anti-patterns about DevOps. Now, the fact that you've hired a DevOps engineer does not essentially mean that you are doing DevOps. We've already explained this, that DevOps is more than tool, or is more than job title. It's a practice, it's a culture, it's a philosophy, and I've taken time to explain that here. So practicing DevOps is not about job title or hiring an individual, and it's not because you use Jenkins that you are DevOps ready. DevOps is not also only about automation, it's also about collaboration, shared responsibility, and also faster feedback, right? These are the various DevOps culture. It's all about how you look at the software development process, right? And also, because you rename your teams from ops to DevOps does not mean that you are practicing DevOps. DevOps is not a job title, it is a transformation. We have to see the transformation of shared culture, of shared collaboration, shared responsibility. We have to see this communication. We have to see that there is no more this independency or isolation that is existing between your teams. We have to see that your teams, they have been given this environment for them to be able to test things, for them to be able to fail, for them to be able to learn from their failure without having mental or psychological breaks, right? We have to see this transformation in your team. We have to see these cross-functional teams working together. We have to see that you are practicing automation. We have to see that there is not everything is now being done manually. You are automating things. You are using infrastructure as a code. We have to see all the DevOps practices that you are practicing, and we also have to see the culture that is existing in your organization. This is the transformation that DevOps bring about. Now, this is the mindset that shift that DevOps has brought about. Now, instead of the blame culture, we now have the learning culture. Instead of one team blaming another for failure, we now have the two teams working together whenever there is a failure to troubleshoot and to detect the cause of the failure, to see what do we have to do in order to be able to solve this problem. Everyone is working in their own capacity to be able to learn together and build together in order to be able to have an efficient software, right? And now we are moving from the silos where teams were working independently. You have the DevOps teams working in isolation, and you have the development teams, operation teams working also in isolation. You now have these two teams working together and deploying software faster and also more reliable software. We also move from manual approvals to automated trust-based pipeline. Instead of writing instead of writing command manually to be able to update servers, to be able to update packages, to be able to deploy application, to install all the various packages and dependencies that are needed for our application, we now have automated trust-based pipeline where everything is being done automatically without human intervention, right? So this is really something that is beautiful. And now, instead of having the ops versus DevOps, each team fighting another, we now have shared accountability. We now have each teams working with shared accountability. These DevOps teams are going to work to make sure that the application is being deployed efficiently, right? So, and everything is being coordinated. This is actually the mindset that DevOps has brought about, and this has solved a lot of problems regarding the software delivery lifecycle. And this is why every team here and there is looking for DevOps engineer in order to be able to join their teams and also help them in their software development. Now, having seen how important DevOps is, how can you begin the DevOps journey in your organization? So, if you are a big organization that you want to start DevOps, it is always good to start small with a pilot teams. Let's say you have 5 different teams that are developing 5 different features in your organization. You can take one particular team that is working on a particular feature and you use them as the pilot teams and you test the DevOps there, right? You give them all the resources that they need, you give them all the tools that they need, and you give them the freedom. You like provide that culture that is necessary for them to be able to work, and then you see the result that is going to do. Like those teams are going to work, they are going to experiment everything, they are going to do everything. And if they bring success, then that is good. And if they face certain challenges, they are going to see how they can be able to solve those challenges. And from all the insight and data they are going to gather throughout their trial, you will be able to know what you have to do and what you have not to do, right? You DevOps adoption is something that has to be done at a smaller scale. Small. It's not just something that you just have to like come and then you change everything at the same time. You might not be able to sustain that particular change. So you start small with one feature, and when there is success, you go with 2 teams, and then the more there is success, the more you are increasing, the more you are learning, and the more you are progressing. Then now, after you've brought out these teams, it's always usually important to map out your value stream. What are the various processes that you do in your organization from the moment that you have a particular idea to the moment where that idea is being developed, where that software is being developed and delivered to the users? What are the various steps that you take? You have to bring down everything. Okay, maybe we plan, maybe we design, maybe we build. You put down everything at a particular stage. You look what are the various things that are being done at every stage of your software development. You write down everything. Now when you write down everything, you eliminate the handoffs and the bottlenecks. What are actually the things that we do that slow us down? What are the various things that we do that slow us down? What are loopholes? What are the disadvantages? What are obstacles that can stop us from doing performance at a higher level? You now look, maybe you have only one person to be able to do code review. You can increase the number of people that will do code review. Maybe there are teams, maybe when requirement gathering is usually taking a very huge amount of time, and as a result of that, the other teams are idle doing nothing. You see how you can be able to reduce the requirement gathering time. Maybe the design teams, they usually design without appropriate collaboration with the developer, and as a result of that there is wastage of time and other. You look at all this, and then you eliminate all these handoffs. What can we do to be able to remove this? What can we do to be able to remove all the obstacles that are preventing our growth? And then now you also have to build a culture of feedback where continuous feedback has to be given at every process and also at every time. And when you do that, you now empower teams with the tools and the trust that they need to be able to work effectively. If you deploy this strategy, you are going to succeed in the adoption of DevOps in your community, right? Now, I promised you people at the end to be able to give you some resources that you can be able to use to practice DevOps. Now, these resources are books that I'm going to be recommending to you that you can either get them online or in the various bookstore. The first book that I will recommend is the DevOps Handbook, which is going to teach you the foundational principles of DevOps, right? And then you also have the second resource, which is the Phoenix Project, which give a simplified narratives of DevOps, right? This is very, very good. You can read the book and then you are going to have narratives that simplify DevOps. And the third resource that I will recommend to you is Accelerate the Science of High Performance. Look for all these resources and use them, and not forgetting the last resource, which is site reliability engineering. That is Google's production grade for DevOps. Do not try DevOps like you have to must read. This is a must read resources for you. Even if you don't want to read anything here, read at least the DevOps handbook and also the site reliability engineering book. This is going to go a hard way in helping you to be able to master DevOps and also deepen your knowledge. So with all this said, you don't do DevOps, you become DevOps. DevOps is not a tool, but DevOps is a culture. DevOps is a philosophy. DevOps is a practice. DevOps are principles that when organization practice is going to get them a highway. So if maybe while reading, looking at this video, you have any problem, you can let me know in the comment section. And please do not forget to subscribe to my YouTube channel Cloud and DevOps Voice, so that you'll be able to get related real videos that I have done. And you can also go and look at the first video that I did on AWS cost optimization. And if you have any project that you want us to work, then I'm ready for us to be able to work if I am available. Thank you and see you in the next video.